I hope that you do not fall asleep just because you had lunch just now, but I can promise there are a couple of maybe a little bit funny slides. And if you don't laugh, I will tell you what I thought was funny anyway. So this picture shows something. Any idea what we see here? Any idea what the context is? Do you see what I have a screenshot here? Yeah, so it's a commit log from a Git repository from my team, and it shows that we have made a couple of reverts, right? And yeah, there's like an initial commit, and there are a revert of that commit, and then there is a revert of the revert, and then there was a pull request because to keep that initial commit, and then there's a revert of the reverted revert of the revert, and so on. And this was a problem for us. And why do you think we did it like this? Was it a mistake, or did we just have to do it like that? The problem we had was that we had access to only one single test environment. So we had testers in our team, we had developers, and we had a couple of other roles as well, but the application was running on an on-premises server, in a classic IIS server. So for us to get additional test environments, we had to submit a support ticket to the IT department at our big client, and then we had to wait a couple of days. So it's the opposite of on-the-fly creation of environments. So not an ideal process, obviously. And as a consequence, since we only had this one single test environment, all the features that developers were working on, they had to be tested in the same environment. And in order to not overwrite each other's code, of course, then everything has to be merged to the same branch, right? So that's the develop branch. It could also be named test. Maybe a little bit confusing, but it's called develop, and it's merged into test. So the main branch, that one deploys to production, and the release branches, the branch to the pre-prod, it doesn't matter. But the feature branches, and this is supported, that doesn't deploy at all. So when all the features were tested okay in develop branch, then we merged develop to the main branch and went into production. And as you can maybe understand, that gave us a couple of problems. Yeah, hello, I am Christopher, and I am the competence lead for Azure at 37. I am also a solution manager at Alfa Laval, which is my current client. I'm based in the Lund office, and I am also a lead consultant, and at Alfa Laval I have the pleasure of working with a couple of colleagues. They look like this. So some of them are from 37, and they are colleagues to you as well, of course. Let's see if you can say who this guy is. No, he is Johannes. Boom, and he's our Scrum Master, and this is Maximilian, he's a developer, and this is Pontus Franzén, and this is Sofia Larsson, who's a developer. So today we are going to talk about three things: how feature environments helped us to improve the way we worked, how that got our developers happier, our testers got not so frustrated, and our stakeholders at my client got their stuff much earlier than before, delivered. And since I happen to work with Azure at my client, and I'm in the competence group for Azure as well, that's where we're going to use Azure as the example of telling this story. But of course it applies to all cloud computing services out there. And a feature environment is a short-lived environment that you spin up on the fly with one single purpose, and that is to test something isolated from everything else. So you don't want to have untested features in the same environment, because you want to be able to deploy that single tested feature as soon as it is tested and done, because there is really no reason for it to wait until it goes into production. So you can, in the best world, you can have as many feature environments as you want, as you can see in this picture. And the process before that we had, that was causing us trouble, was that the developer, they branched out from develop and created this feature branch and worked a couple of days and then merged that pull request to that code to develop. So every code, all code went into the test environment. The tester up there did the testing and then gave feedback, of course, to the developer, because obviously not always the test will pass in the first attempt. So there will be recommits and changes and reverts. And of course, we don't want that in the develop branch, because then it's gonna end up with a couple of unrelated commits that are not really anything that adds value to the feature. And as I told you, whenever everything is tested and developed, then we can merge develop into to main and go into production. So we worked in these 2-week sprints, and when at day 1 everyone started to code, of course, and then a couple of days before the sprint end, someone has to say, now it's a cutoff date. Now we have to say, stop, you can't put any more into develop, because then we have no chance to test everything before the next sprint starts on Monday. So it's crazy, of course. We can't work with that. But it was due to this legacy setup that we inherited, which prevented us from creating another environment to test in. So that's like the key showstopper here. So every now and then, of course, we ended up with a situation where some stakeholder came to us and said, hey, we need that feature out now because it's tested. Why are you sitting on that one? You can't wait. Okay, so but we have 10 features in the test environment right now that our developers has done this first part of the sprint. So what could we do then? Then we had to do some real ugliness by cherry picking that single commit, right? But even worse, if that commit, if that feature consisted of several commits, which it's like always did because the testing was done in the development, then we had to cherry pick out like 5 or 10 commits. And I don't know about you, but I don't think it's a great way of working at all. And we can also turn it all the way around and say that, okay, so we have 10 features in the environment in the develops, and we have 9 of them are tested, but the 10th, it's blocking us from going to production. How long can we wait? So maybe we have 9 features of very big value for the business, but this 10th feature is maybe, what if it's like just a minor fix that doesn't add any business value? Then it would be ridiculous to like wait, but we had to wait. So then we say, okay, so let's cherry pick out 9 features. No, let's not do that. Super horrible. Let's instead revert that last commit. And that's what happened in the first initial slide, of course. So a lot of that craziness in the commit history is because this reverts of revert. So whenever you revert something, you still want to keep the reason for the revert was not that the code was wrong, so we want to keep it, so we had to create another pull request keeping that for the next sprint. So and also there is no way for a developer to test his or her code local. Local, of course, but in outside the local environment, because we couldn't set up this new environment. So we would rather have a situation where the developer can say that, okay, it seems to work on my machine, but experience tells me that that doesn't necessarily mean that it works everywhere, right? So we better have a situation where that developer could move that code somewhere else and test it there before giving it to the testers. Yeah, so my team were frustrated about this. We thought it was very painful, and we sat down to discuss it. And then some of us had heard a podcast episode with our colleague Joss, who talked about feature environment at her client, and thought, let's investigate that topic. How hard can that be? So what we came up with was another process which was enabled because in the same time we migrated this application from on-prem to Azure or to any cloud, but in our case to Azure. So what we can do then is to simply have the main branch and throw away that develop/test branch, just branch out from it to this feature and create on-the-fly environment which the developer works in and the tester test in as well. So all the fixes, they go into that feature branch with new commits, and that is no problem because after like 5 or 10 commits or something, the developer can just rebase the commit history and clean it up and create those commits that really reflects the work that has been done. So we do not have any more of commits with commit messages like fix or fix code or this kind of commit messages. So we did this iteratively because it was new ground for us. So the first attempt was to simply see if it worked at all. Just create 3 pre-generated environments in Azure. And then we added a dedicated pipeline for this. So the developer could simply manually open up Azure DevOps, pick that pipeline, and then select one of those 3. And also the branch that he or she wanted to deploy. But it came with a problem, and that is that the developer needed to ask around in the team, like, hey, is environment 1, is that free? Can I use it? Is no, okay, no answer, okay, but what about environment 2? Yeah, that seems to be done. The work that was tested there before, that seems to be done, so completed, so we don't need it anymore. Okay, let's deploy to that one. That could be approved, as you can easily understand. So in our second attempt, we kept the pipeline, but instead of this drop-down list with these fixed 3 environments, we introduced a text box where the developer could simply type in a name, and then we passed that name as a parameter to the pipeline. The pipeline spun up a feature environment with this dynamically passed name. So all of a sudden we could create as many feature environments as we wanted. Very good, but when we were able to do that, we also ended up with quite many feature environments, like 20 or 30 or something. And we scratched our heads, and now it was totally impossible to know which one was used or not. So we had a lot of garbage laying around, and we did another attempt. So we simply thought that, couldn't we just skip the text box also, and on each push to that feature branch, why not simply run the pipeline every time? Yeah, why not? So the pipeline runs, and the pipeline takes the job of finding out a name to give to the environment. And that is nothing complicated at all. It's simply a matter of having a naming convention for the feature branch, something like this, that says that let's give the branch the name with include the ID of the user story or something like that. So then we can, just extract that name, that ID number, and make it some DNS host name safe or something like that, and use that as this parameter, pass it to use it in the pipeline, and then spin up another feature environment. But to address the problem with too many environments laying around, we came up with an idea how to remove them automatically as well. But before that, someone of you might think, what about feature flags? How does that come into this context? And a feature flag is for those of you who don't know that, it's a technique that enables you to enable or disable functionality that is already in the code. So you don't have to don't have to deploy code to enable a feature. You deploy code once, and then you enable it instead. And that is very good for like bigger initiatives. Like you have a target release date. Maybe the business says that we want it to be ready. We don't want to deploy this the same date that it should be used. They want to minimize that big bang release. So please deploy it like a couple of weeks before, and then have it in the environment, and but then just switch on it at this exact date. So that's a feature flag, and it's not a contradiction to the idea that I'm talking about, because it's more like feature flags enables us to do frequent deployments all the time without waiting for release dates. But feature environment that I'm talking about is more about creating quality releases. And some technical details am I not going to dive into, but I will just give an overview of the solution that we created. Of course, we have a pipeline, which is nothing more sophisticated than something that builds and tests and publish and deploys. Of course, those are like the three fundamental steps. But we also added some interesting activities here, which I'm gonna get back to in the next slide, which is the deployment of the resources, the one that forms the actual environment, and also some technical stuff that we had to do to make it work. And the resources, how are they actually created? And this is why when you use something called IaaS, infrastructure as a service, this is where you declare the resources in a template, and you in a descriptive way you declare exactly what the complete environment should look like. And two popular ways of doing this is one is called Terraform, and another one is called ARM templates, Azure Resource Management templates. And what's very convenient about that is that the first time you run it, there is nothing. Then it creates all these things, these resources. But the next time, since it's just declarative, it just looks at and see, is this snapshot of the current environment, is this exactly what my template says it should be? If it is, then nothing happens. So you can run it as many times as you want. That's why we can include it in the pipeline. You just run it over and over again. And it has many other advantages also if you're not using them today. So you sometimes you're very good at managing your code in a source control, but sometimes you forget about all the things you click and create by UI in Azure or in GCP or AWS. So you should script them declaratively, not in a script way that is like a bash script. You should use a template that declaratively says what it should look like. And what we have here is nothing complicated, and that's why I'm not going into it, but it's just a website and some key vault configuration and stuff. It's just an example. But then we thought, all these environments, should we just have them laying around? I already mentioned that it creates a mess because there could be like hundreds of environments, and who wants to be the one who goes in and cleans them up? No one, because then might need to ask like 100 times if it's been used or not. And another reason, maybe the most obvious, is that it costs money, of course. And yes, I know that in Azure, in particular, you can have 100 applications running at the same time. Simplified said, the cost model is more of a hosting plan model. But anyway, it's still everything costs money at the end of the day. So just as important as the money is the carbon footprint it gives. At first we thought that, yeah, let's just make them idle after inactivity. Yeah, that's a good idea. But why not go all the way and automate even the shutdown? Because we do want it for the housekeeping as well. So then we thought, what is the actual trigger for automating that part? Well, and we thought that, yeah, okay, so the code is deployed on each push. What happens then? Yeah, they are testing it iteratively. Meanwhile, the coders are coding, and then we had a pull request, which should be approved by both the testers and the developers. And whenever that pull request has been reviewed by all the reviewers, it can be completed, right? And then I said that code merges to main and goes to production. And that's where we should shut down the feature environment, because we don't need it anymore then. So in other words, the pull request being completed or abandoned is the trigger that we want to listen to. And then for Azure, in our case, there happens to be an event that is sent out when you complete a pull request, or actually when you update the pull request. So that event will include some information that we can use to shut it down. In Azure, it's called service hooks. It's not super obvious where you find that and how you set it up, because it requires some higher permissions you maybe don't have. I didn't have it, so you have to make someone else enable this service hook. So if you don't find it, it's probably because of permissions. But anyway, with that setup, we will end up with a little ecosystem that spins up things on the fly and shuts them down when they are completed without any user interaction. And that little event is sent out from this service hook, and it's called something like that, get pull request updated. It's not that very important, but it includes the current status of the pull request. We look for that string which says completed or abandoned, and then it also includes the name of the source branch that was used in the pull request. So with that name, we can extract we can extract the name that was used to create the feature environment. And then we configure that hook to send away that event to an Azure function, or in AWS, a Lambda, or a Cloud function in GCP, of course. You can send it wherever you want. It's just an HTTP post. Nice, and it was almost done, but not perfect already, because we had some challenges. One is that we integrate with other systems, of course, and I guess that like all applications do. And of course, we cannot control those. We couldn't spin up corresponding feature environment for that integrated system. So we couldn't there is a one-to-many relationship between the integrated system and our feature environment. So we had to adapt to that because we couldn't like change anything in those. We cannot, we don't own the test data. We share it with other teams. We had to adapt ourselves to that. And also, this was all about automating this. We couldn't do it at first fully because there was some resources in Azure that didn't really belong to this short-lived feature environment. For example, this Active Directory is something you use when you use identities. You authenticate and authorize against Active Directory, but that's like a standalone application, you can say, in Azure. So you create that one, so but it doesn't belong to the feature environment. So we had one single application, Active Directory instance still, and which we needed to add a value to. And to be more specific, you know, when you try to log in, you will be directed to a Microsoft form in which you enter your name and password. And on a successful login, you will be redirected back to the website. So in order for Active Directory to like approve that redirection, you have to add that URL that you want to redirect before into the Active Directory. And so that's like a manual process where you open up the Azure portal, you browse your way through into the Active Directory, and then you open up that text box and types in that actual feature environment URL. And it would be boring if that should stop us from being 100% automatic, but we found a way, and that's actually to just use some REST API calls to Azure, which we learned that you can create almost everything with that. So here we just get a list of the current values, and we add our value, and we send a patch to modify it. It's very simplified, but just want to include it because I want to mention that there is like ARM templates for declaring things, there are pipelines for running things, but there you can also have command line stuff going on if you want to do something that's not really in scope of those other two activities. Yeah. Finally, then let's check if we met our goal. We want to be able to test multiple features at the same time. We don't want to have features that are blocking other features from being deployed. We want to go to production right after testing if we want to. We want to have that option to do it. So we don't want to be delayed by other. We absolutely didn't want that ugly commit history. Now it's clean. And with all this, I think our stakeholders said that we had a better, faster time to market. Nice. And to wrap things up, I have created this super small repository. Just put a couple of example files there, what I've been talking about, because if you find this interesting and you recognize the scenario from your own client or something, you, of course, as always, you don't have time to do this on Monday, but you can maybe write a mental note or post-it note when you get back or something and write feature environments and then forget about it. But then in a couple of weeks, when it pops up in the backlog, you can think that, okay, there was this place where I could find a couple of examples, and then we can have a conversation about it. So I hope that can like bring you with you today some ideas how you can implement it yourself if you find it applicable for you, if you're in a similar situation. Yeah, and hopefully this same setup works for you as well. That's it, and yeah, that's it. Is there anyone who have experienced of this? Either you have done this, or you have not done it yet, or you think it's a bad idea, or something. Yeah?
So testing and developing features at the same time. Do you ever run into some semantic conflicts when merging different features? For example, let's say one feature references a utility that another feature actually deletes, and the merge conflict doesn't actually show up because it's a semantic merge conflict. And in that case, you only ever see that in production because you don't have any staging environment.
No, I understand what you mean, but that hasn't been a problem for us. At least not as long as we have been into this new process. No. But how could you solve that? Any idea?
Yeah, well, one thing is having a staging environment, but
yeah, one thing is that, but it comes with too many problems, I think.
Yeah.
Yeah.
Would it be possible to merge those two features into another?
Well, that depends, because if you have multiple features, then any one of these features could actually impact the product, right? So the idea is to integrate as fast as possible.
Yeah.
And you can only do this if you have like a common branch.
Yeah. Well, what we have done in those cases is to have like the same feature environment for a couple of features.
Yeah, but you have to do a little bit.
I mean, yeah, if you try to integrate within your feature branch, but that's just promiscuous integration. I don't think it's. I'm not sure actually. That's what I'm asking. Why I'm asking, because maybe
What
I'm
about,
making too big of a deal about it.
Maybe deprecation, so you can mark some features deprecated, or when you change the functionality, you make a new one that is almost like the old one, and you deprecate the old.
Okay, that's one way to actually
Get some duplication.
Yeah, sure. Okay, that could work.
But some of you raised their hands. Yeah.
So thanks for the talk. I mean, and this, what you just described is, ideal world, and we were struggling to implement this in our client in Oxford. However, there were some obstacles. For example, you cannot afford having a big cluster, like a data warehouse, Redshift cluster for every feature branch, feature environment. So we ended up with team-specific test stacks. But again, the problem is that within a team they have to communicate. Okay, I want to deploy my feature to our test team-specific test environment. That's where we at right now. But I like the idea, and also what's good here is that you migrated from. There are two types of workflows. First is Git workflow, where you have develop branch, staging branch, production branch, and associated environments. And the other one is GitHub workflow, where you have. Also it's called trunk-based development. So you have only feature branch and then main branch. And that's what you implemented, and I like this idea. It allows you to be to deliver features very quickly. And not wait.
Not wait, yeah. Because at the end of the day, we're there for the business, and they want to have their stuff. So it was impossible to have the old way in the long run, because we couldn't get our stuff out.
So the bottom line is, it depends on your system and depends on your requirements. Maybe costs are an issue as well.
Yeah, it could be an issue, if, like you say, if you have this resource data warehouse, but that is expensive. Then you might not want to create 100 of them.
Yeah. Very nice.
And then you have that dependency to that one. So but it's better than nothing, I guess.
It's great that it works for you.
Is there anyone else who have done something like this, or are you testing in one environment?
We are kind of close to this, trunk-based. Our DevOps guy is trying to push us towards releasing more often.
Yeah.
But what we do is that we have one develop branch, and every feature branch gets merged into there. and most of them do some tests, maybe by naming. I imagine maybe if you don't name your PR branch feature, it doesn't auto-deploy, something like this.
Yes.
Yeah, we're trying to do something in that direction as well too, and we don't have any chance to get new environments. But what we do then is whenever we deploy, we do that manually, and we have only one test environment, and we do that manually. So we say in Slack /deploy type, add the password, and then we get it into a test or integration. There's so we have dev and we have test. These are used by QA. Then we have something called staging or pre-production. That is, whenever something is merged, it comes there. So you can always verify if we deploy to production today, that's what they get. And also some training is done there. So we have a little bit of guinea pigs in that environment as well. And then
Don't you mix untested and tested code? No.
Yes.
Yeah. So that's problematic.
Usually we mark. So in the PR we say this needs testing or this doesn't need testing. But it would be nice to automate it a bit. And we have slow pipelines doing end-to-end tests and such. That's but it's Firebase, so it's very expensive to roll up a new environment. So we have to request and ask and wait for months typically.
Okay, that's the showstopper, because otherwise you could maybe apply the same IDs. Yeah.
They are building up some emulated options. So anybody on Firestore, it's possible to do, but it's a bit of work.
Yeah. I like emulated in local.
Yes, you need to have a kind of fat instance to be able to spin up all the emulators and stuff.